So Tullio, I won't make a very long introduction. You're a very humble and modest person that doesn't like those kinds of things, but I still want to say a few words. Tullio Jappelli is an economist that has been studying consumption and in particular also retirement and various other subjects, also finance. He's very dear to us because in part when I started my career, when I was a student, we were part of a network that Tullio actually was the director of, the RTN network in Europe, where a lot of the very good people in Europe, including Tullio, were there, and as PhD students we would learn a lot from the presentations they would give and the comments they would give us. So we're very happy to have Tullio Jappelli today give us a lecture on consumption and portfolio models, and especially how we use survey experiments to actually do that. So thank you, Tullio.
Okay, so thanks for that. So thanks for the invitation, and also for reminding me of when I was running the network on the economics of aging, now that I'm aging, and the network does not exist anymore. But so thanks for this invitation, and actually thanks to Carl, because it was also an opportunity for me to, rather than present just one paper, to maybe think of what I've been doing for the past 2 or 3 years, and also what I plan to do for the next, maybe 1 or 2 years, or perhaps more. So I also should apologize with Stefan, because I will use a very broad definition of what I mean by experiment. By experiments I mean all sort of questions, beliefs, on subjective expectations, on probability and so forth, on randomization, that one can run with surveys. So some of this is truly an experiment, but some is not. So just a short introduction on, say, the economic history of the consumption literature. So for about 20 years or so, between, say, the 60s and the 70s, people were checking the implications of consumption models through essentially reduced form regressions, from saving or wealth or consumption until maybe the 70s. And then there was this period in which people were estimating other equations for another, say, 15 or 20 years until maybe the year 2000. And then there is this approach by simulation, which was started really by Lynch's in 2000. I've been following in the past 2 or 3 years with co-authors, a different approach that is based on surveys and on designing surveys, or asking questions in surveys, or designing surveys to test some specific implications of consumption models. And I think this is a useful complement to other approaches. So I don't want to say that the survey experiment approach is the best one, but it's useful as a complement. So what I mean by survey experiments, or at least the survey experiments I've been interested into, are situations in which you consider some theoretical model, perhaps the one that you like, or perhaps one that you dislike, and that you want to check with the data if it's valid or not. And then you write down or derive some specific assumptions. This will be your sort of null hypothesis. And then you devise some suitable experiment, and then you have the problem of the identification and so forth, the heterogeneity, blah blah, and then you check the results, and sometimes you can validate these results because of empirical evidence of your own simulations. And I will show you a couple of examples. I have here 4, but I promise I will not talk about all 4, because at some point you want to go to dinner or perhaps ask questions. So the first one is, consider these as examples. They are connected in some way, but they are in different papers. The The first one is it's a paper we completed, and we are essentially also the revision is completed with the Jappelli, with whom most of this research is going on. It's about buffer stock model and testing some specific implications of the buffer stock model. Another one, which we completed a couple of years ago, is about testing the conformity of the consumption function, which is the one also implication for the buffer stock model. And the third one is about testing implications of intertemporal consumption models about different reactions that people should have on transitory income shocks, positive or negative, small or large. And the fourth one instead is on portfolio. This is why the title is on portfolio, and is about getting issues like whether the hypothesis of constant rate risk aversion is consistent with the data or not. And then I have also other sort of related projects. For instance, one is on income effect on labor supply and search, also with some experiments, or house prices on consumption and so forth. But those I think we have time to talk about. So what about the experiment one? So the experiment one is actually going to be going to spend most of my time talking about this experiment one, because I think it's a way that I think an ingenious way in which we found after fighting with these data sets to exploit survey information to test specific implications of a theoretical model. So in a nutshell, what we are doing is that we are taking the buffer stock model, and I will try to convince you that the buffer stock model has one specific implication, that when people receive some permanent income shock, say promotion, that would be a positive permanent income shock, or a demotion, which would be a negative income shock. In the case of a promotion, people will adjust consumption, but also people need higher saving to ensure this higher level of consumption. And so in this particular model, permanent income and what in this model is called target 12 move 1 to 1. And we are going to test this implication of the model, and then we're also going to test what we call like a positive implication. Do people actually do what they're supposed to do according to the model? I will be more precise. So the research design is the following. We are going to estimate a particular parameter that is implied by the buffer stock model, and what we find in this paper is that people actually understand what they should be doing. So people understand, and a bit precise on this, that they should raise their target 12, their amount of, say, precautionary assets, in response to permanent income shock. But then we also find that people actually adjust their wealth. When they are below target, they will increase their wealth. When they are above target, they will reduce their wealth. So this is not something that we have done. This is a classic model for buffer stock. There are various versions. This is Chris Carroll's version, and the model is completely standard, so I could spend very little time on this. This is a model that everybody knows, so that people maximize utility. There is a dynamic value constraints in this version with infinite horizon. The income process is also quite standard, so there is a permanent shock and the transitory shock and some probability of unemployment. And the implication of this model, because people are impatient, they would like to consume, but income is risky, so they would like to save. These two forces, imply a constant, for some parameter values, a constant ratio between cash on hand and permanent income in steady state. Okay, so W star divided by T is cash on hand, and this is a star because that's the optimal level of precautionary asset, and PT is the permanent income, and this is equal to X star. And so you see there is no T in X, but WT and PT can vary over time, but X is constant, and this is also not from our paper. This is from Carroll's work. You see that the vertical red line is the stable cash on hand to permanent income. If you are to the left, you are below target, and so consumption growth is positive, and you go to the target, and you are to the right, So let's now see what this implies in terms of what people should do. People should maintain this target wealth level of wealth that is proportional to permanent income. So the implication that we're going to test is that any revision in permanent income would translate into a proportional revision in target wealth. Exactly the example I was making before, you are promoted, your consumption goes up, and then you need more assets to ensure that level of consumption, and vice versa if you are receiving a negative permanent income shock. Then one can ask the other question, if people are below target or above target, do people adjust to this target wealth or not? So let's see how we, okay, so this is an example. This is, I think, just to make this argument more clear. So this is an example with a particular utility function. You see that this x star, it only depends on parameter. And the parameters are like impatient. If people are more patient, if here is a typo, then this x star will be higher. If there is a higher probability, say, of unemployment, this ratio is higher. So this ratio essentially depends, the target wealth of people in this model depends on preferences and depends on the income process. So it's individual specific. Everybody has his or her own target, and everybody should aim to get to that target according to this model. So what do we do to build this our empirical test? First of all, we add an I, like for an index for the individual or the household in this test. So you have a xi star is equal to that ratio, and this is a unique and stable value that varies across individual, but I was mentioning before. This ratio is affected by preferences and also affected by the income process. So think about, a collection of individuals. Everybody has a different target wealth over permanent income. So this complicates things because the way we want to proceed is that we want to test precisely the duplication. So from that ratio, you can consider a log linear relation. You take the log of W star IT, which is equal to fixed effects or individual effects that I log PIT. And now let's assume, I haven't said how we go about empirically to estimate this, but suppose you know and you the permanent income of everybody. Suppose you observe this target wealth. Target wealth is not your actual wealth. Your target wealth may be very different from the actual wealth. So then you have this log linear relation where log W star, the target wealth of each individual, is equal to, it's proportional to log permanent income, and the implication of the model is greater than equal to 1. So this is what I meant at the beginning. We take a particular model, a specific model, the buffer stock model, with all the assumptions built into that model, and we derive this implication of the model that, to our knowledge, has not been tested so far. So this equation is what we will estimate, but there are still problems with this equation. First of all, there is this individual effects theta I. So can we use cross-sectional data? Well, if we use cross-sectional data, then think about the previous equation. Then if this covariance, and go back here, if the covariance between PIT and the fixed effect theta I is not equal to 0, you cannot estimate this equation with OLS, because you have a non-integral variable that is potentially correlated with permanent income. And this is like to be the case, because people with, say, high taste for saving are probably also those who are, say, hardworking and therefore have high permanent income. So in general, we cannot use OLS, but we can perhaps use panel data. And if we have panel data, what we can do is that we can check whether the growth or the change in wealth, in target wealth, is proportional to the change or the growth in permanent income, getting rid of the fixed effect. So this is what we are going to do. But still, we have problems. And what are the problems? There are two problems. One problem is that W star is not observed because the target wealth of everybody, the individual target wealth is not observed. And the second one is that permanent income is also not observed. So what do we do? About target wealth, and here comes what I loosely call the experiment, comes questions that is asked in the Italian survey of household income and wealth, and is actually similar to a question that was asked previously in the survey of consumer finance, for which we have direct evidence. So we actually ask people what is their target wealth in a way that I'll show you in a minute, and then for permanent income instead we estimate, we extract the permanent component of income. So in our test we don't rely on consumption essentially. However, we need panel data, so it's actually a bit demanding in terms of data, and actually panel data of considerable length to estimate in a meaningful way the income process. Okay, I'll come quickly, after this on how we do in practice to estimate beta, this relative coefficient. But then there is another part of the paper that, suppose that I observe in a survey that people react to permanent income shocks by raising their target. The target is something they have in their head, but it's not something that we can observe, in their bank account, because their bank account or financial asset could be very different than what people actually have. So what we do is that we can actually check whether people who are away from their target, you see, say, WIT minus 1 is your actual wealth. If your actual wealth is less or above your target wealth, then you adjust. And this is like like an adjustment equation. If lambda is negative, it means that people with wealth above the target are actually going to reduce wealth, and people below are actually going to increase. So we are going to check whether lambda is negative or 0, and then in the end of this project, we actually going to produce a simulation to see what a model really implies also in terms of adjustment. So for instance, if lambda is equal to 0.5, means that you close the gap between wealth, target wealth and actual wealth in 2 years. So data, okay, so this the Italian survey, similar to many other surveys, has demographic, income, consumption, wealth, but crucially it has a direct survey question on the buffer stock of wealth, and this is the question. So the question, I will read part of it, that people save in various ways. Then there is a mention about contingencies, so one reason is to protect against contingencies, such as uncertainty about future earnings or unexpected outlay. So the question is framed in a way that should elicit proportionally assets. About how much you think you and your family need to have in wealth to meet such an expected event. So this is the question that we use, and this question has been repeated over time. And so these are sample meals. Let's look at median. So reported target wealth, the amount that people report in the survey they should have for proportional asset is about 20,000 euro. Consumption is also about 20,000 euro. And income is about 20,000 euro. And the ratio between target wealth and income is about 0.9. So these are our data, and this is a distribution of the difference between actual wealth and target wealth. So actual wealth here is really cash on hand. So your monthly income plus your financial assets, your liquid wealth, and you see there many people who are roughly on target, but there are many people who have wealth above the target, the declared target, and many people also whose wealth is considerably below target. So I was mentioning before, what we do in this paper is that first of all we test whether changes in W star are associated to changes in permanent income, and then we are going to check if people who are below or above target actually tend to reduce or increase wealth in order to go back to their target. So this is just descriptive. We are not going to use consumption, but just to visualize what we do, suppose permanent income is equal to consumption, and consumption is a reasonable proxy for permanent income. You see that there is a strong association between consumption and target wealth. People with high consumption also report high target wealth, which is more very natural, and also in terms of growth rates. People who exhibit higher consumption growth also over the panel report increase in this proportion. But this is just descriptive. We're not using consumption in the regression. So what's our research design? Our research design is to do GMM estimation. So we take the same income process of the buffer stock model that I showed before, which is the standard decomposition of income into a permanent transitory component. So P is the permanent component and Z the transitory component, and X is just demographic variables, age, education. And then let's take the source difference of that. And the target wealth process is exactly the same equation that I was showing before. It's log target wealth, then some demographics and beta log permanent income. And we want to estimate beta, but when you take the first difference, this is what you get. And then you can check, I don't really have the time to go into the details, that there are essentially 4 parameters to be estimated. One is the transitory income shock, the other one is the transitory permanent shocks, one is beta, of course, and then there is this variance of the unobserved component of target. So we have this moment restriction, and you can see here that the system is actually well identified, but you see in order to get beta, you need to estimate this other moment. So we do this by GMM, and this is what we obtain. So to our surprise, a bit in a way, we found beta that is not statistically different from 1. So we find that the hypothesis, the implication of the buffer stock model, that target wealth moves 1-to-1 in response to permanent shock is actually consistent with the data. I mean, that's our null hypothesis. I should also say that we find considerable variance of target wealth, report target wealth, that is not explained by movements in permanent income. So there is a lot of noise. So the variance there, you see, is 1.0. The other 2 parameters actually close to what people usually find in transitory. The variance of permanent shocks of 2% is consistent with many other papers, and the variance of transitory shock is 5%. And we have found this also. Okay, we do other things for robustness, what I don't want to go into, but we can extend this to situations in which we check whether target wealth also reacts to transitory income shocks, not only to permanent shock, and whether preferences change for the income process change over time. You can also, adding a moment restriction, you can also do this. And then we also some heterogeneity. So okay, so this is step 1 of the paper, but this is say not enough, because some people say, okay, yes, we found that people, modify their target wealth, but what do people do in practice? People adjust their wealth to get to this target or not? So far, I think if you believe in this result, we find that people understand what they should be doing, but this is different than actually doing what you should be doing. So we can now, run an adjustment equation, so to speak. So we can plot the change in wealth on the vertical axis, and the lagged difference, or wealth gap, the difference between your actual wealth and your target. So to the left, people who are above 0 are people who have too much wealth relative to target, and you see that the change in wealth is negative. And on the left-hand side, instead, you have the people who are below target, and you see change in wealth is actually positive. And you see also that there is a bit of asymmetric behavior the adjustment below is actually faster than the adjustment above. So we can actually estimate this equation, and we find the coefficient of minus 0.19. And controlling for other things, we can also do some IV estimation for possibly immunogenating. We find the coefficient is actually minus 12, but more interesting, we can estimate the two separate lines, the negative and the positive portion, and you see that for lagged wealth gap, the coefficient is minus 0.1, and for the lagged wealth gap less than 0, the coefficient is actually larger in absolute value. So this means that people who are below target adjust their wealth more quickly to target than people who are above. Okay, so this is sort of end of step 2. Step 3 of the paper is, okay, like you didn't tell us whether the buffer stock model actually predicts this type of adjustment to target when you are off target. So for this, this is essentially step 3, the last step of the paper, is to run in simulated data. So we take the model I showed you at the beginning, we simulate the data, and then we run in the model, in the simulated data, the same adjustment regression that you have seen in the actual data, and these are the results. Of course, the results change a bit depending on, say, the interest rate, depending on the gamma, which is risk aversion. But take, for instance, the last row here is data, and this is the same regression I was showing you before. Let's look at the last two cells. So data means minus 0.26 for lambda below, and for lambda above is minus 0.10. So these are the same, these are the coefficients from the data, and you see that in simulation we can actually get values that are quite close, minus 8.23 and minus 0.11 for very reasonable parameter values. So to us, this, and this was also a bit of a surprise to us, because we didn't think that we would get so close to our estimate. It actually makes sense. The adjustment is stronger from below, because people that are sort of poor and has a higher utility cost to have low assets if you are hit by a bad income shock. So this is a summary of this sort of first experiment. Again, so we used the survey data, so that's why I call the experiment, or data not belief. But note that this is, in terms of data, is demanding. I mean, you cannot do this with cross-sectional data. You need a relatively long panel data to get rid of the fixed effects. And this, I think, is a common story or a common problem that one has when one does these experiments, because people are different. You need to control for that. Questions on this, or you can have questions?
I'm suspicious that you guys, you and Luigi, over the years, you taught the Italian population the buffer stock model. That's why it works.
Okay.
It's so good at
So experiment 2, I will be, I will sort of summarize, much more these other. So this is actually a paper that we wrote a couple of years ago. I want to discuss this now in preparatory, because again we have the issue of fixed effects, and because again we sort of address this issue of fixed effects by using panel data on these sort of type of subjective questions. So the paper is about testing the concavity of the consumption function. So this is a consumption function, and we know that when you have, say, certainty equivalence or quadratic utility function, the consumption function is linear, so the marginal propensity to consume is the same for everyone. But with models like the buffer stock, but not only, say, when you have precautionary saving and liquidity constraints, you have a concave consumption function. So look at the change in income, and change in income is the same, but on the vertical axis, the rich have a marginal propensity to consume, that is much lower, is in this picture, than the poor. And the reason is simple, just the rich they can buffer better resources. So think about receiving a negative income shock. If you are rich, you can absorb that easily. If you are poor, you have to cut consumption. So that's the standard consumption, concrete consumption function that's been around for many years. So what do? We ask, that's sort of the experiment. We ask a question that now is being asked in many different surveys in slightly different ways, like in the Fed, also the ECB has an online questions, and in smaller surveys, this question is asked in many cases, but the question is that how much would you save and would you consume? Some people ask this as a proportion of income, some people ask this as a lump sum money, some people ask about shocks and so forth. So suppose one wants to check whether the consumption function is concave, well then you have to, what you can do is that you can estimate an equation of this form that the marginal propensity to consume, which would be the derivative of that function, depends on x. Instead, if it was linear, then beta would be equal to 0. So this is the test. The test is whether beta is actually negative and the function is concave, or beta is equal to 0 and the function is linear. Now what's the problem here? The problem is sort of, in a different context, is similar to the problem I showed before. Because think about estimating beta. Of course, you have Fi in the first equation. Fi is an individual effect. It's a fixed individual effect. Why? Well, because we know that the marginal propensity, the consumption function in general will depend on the income process, can depend on preferences. So it will be different for different individuals. So if you estimated that equation, the OLS would be valid. You cannot estimate that equation by OLS, or you find suitable instruments, or what we do, you can take first difference and get rid of the fixed effects. But in order to do this, you need to have these questions repeated over time, at least twice and perhaps more time, which I think is useful exercise in general in these surveys to check whether people respond in a consistent way over time to the same question. So, okay, this is just a picture of what we get. So we eliminate the bias, the fixed effects, and we estimate the change in the marginal propensity to consume over the change in x, and that's this is the lower graph here. And when we do this, we show that in fact there is a difference between OLS and fixed effects. And so this is one more case, one situation in which it is useful to have tandem data or repeated observations on these subjective questions. There is also another possibility to ask the same person different questions, for instance on positive and negative income shocks, and then consider the difference for the same individual across these questions. So this is what actually we do here when we talk about, when we consider Dutch data. So here I want to be even, shorter in time, so that essentially we ask similar questions about positive and negative income shocks, similar to the one we asked in Italy, but we ask the same person actually 4 questions rather than only one. So we ask about what would you do if you had a positive income shock, or if you had a negative income shock, and then shocks of different size. 1 month, or say you can increase it if you want, and then 3 months, or you can have it even higher. And then we ask what people do. Here again, one can simulate a model, and one can test prediction of the model. For instance, if you simulate a standard model with proportional saving, you would find here is the response of consumption to positive income shocks. And you see that the marginal propensity to consume is not flat, but is higher at lower level of wealth. So this is the same property, so to speak, of the concavity of the consumption function that I was showing you before. This is for a positive income shock. However, for a negative income shock, you have a stronger response. And this is what you get from the simulations. If you are poor and you get a negative income shocks, the only thing that you can do is you can reduce consumption. So this is the reason why you have a stronger effect, higher MPC from a negative income shock. So notice that the MPC is always a positive number because here you have a negative income shocks divided by, a negative consumption divided by negative income shocks, so minus and minus is always a plus, but here we are considering a negative income shock. So the prediction is that negative income shock should be associated with higher MPC, and in fact, this is what we find, and then we refine this by looking at the difference between the various responses, also for positive and negative. I don't want to go too much in detail, but just to say that the approach that we're trying to take is to consider some model, to have some benchmark, and then to try to come up with questions or research questions that can, sort of be in agreement or not, or test these implications. So the final thing, do I still have like 5-10 minutes? Yeah. So the final thing is on portfolio, which is, if you want a bit of a development of the previous thing. So here, instead of asking hypothetical questions, okay, so here we ask hypothetical questions, but instead of asking the same hypothetical question to everybody, we randomize the sample. And the issue we want to address, forget about the stock holding issue, but we spend a bit more time on the share of risky assets. There are many, many people who have tried to check and to make whether the share of risky assets, or say the propensity to take risk in financial markets, is higher for the rich or for the poor, and this issue actually is very closely related to the issue of risk aversion and whether it is constant or not. And people have devised very smart ways of doing this. For instance, this is paper by Calvé and Sodini on twins, and they check what twins do because twins are different at some point, but they have the same characteristic. Or there is this data set on Sweden by Cesarino and co-authors on lotteries, real lotteries. So they've checked what people do after receiving the lotteries and whether people actually increase or not stock holding. They actually don't do risky asset shares. They look mostly at whether people invest in stocks or not, and how much after receiving real lotteries. Because in so many millions of people, you get some people. Of course, you have very few people who receive very large lotteries. And then, of course, there is a more traditional approach that some people have taken by using panel data to check what happens to the, how the risky asset share changes when the wealth changes. So what we do, this is, I think, very more, I can probably say that this is more like an experiment than the others. So we consider this ECB survey, it's an online survey on 6 European countries and 10,000 households. We randomize in 5 subsamples, and then we ask in the different subsamples, imagine you win a lottery, so the difference is that in Cesarini's data set, it's a real lottery. Here, it's a hypothetical lottery of 5, 10, up to 50K, and then what would you do? If you win, say, 50K, would you consume, would you invest in financial assets or in pay debts? So this is a standard question. That's the way also Shapiro and others who actually started all this research, that's the way the question is usually asked. But then in addition, we consider the amount that people save in financial assets and ask them, what would you do? What kind of financial asset would you invest into? Would it be current accounts, bonds, retirement products, stocks and shares, or mutual funds? So because this is randomized, then we can exploit the variability of the responses across the subsamples to identify the relation between changes in wealth. These are wealth shocks, actually hypothetical wealth shocks, and stock holding or the discount share. And I don't show you but actually the randomization works quite well in terms of demographic characteristics, income, and so on. The survey agency actually did a good job in effectively randomizing these types of samples, and then we can, for instance, see what happens to stock holding as you move from 5 to 50K in terms of stock holding. So we find, for instance, an increase in participation of about 10 percentage points for the longer size. So this is okay. It's not super interesting because lots of people actually have done this. One can claim that this is genuine wealth shock, but one can compare with empirical evidence. Cesarini finds similar numbers in real lotteries using Swedish data. But what we can do we can also look at the change in asset share. So we know the financial wealth and the risky asset share, the actual share that people had before the experiment. Then we know how much they would hypothetically invest in this lottery, so that we can compute the change in their asset share, and the change can actually be positive, it can actually also be negative, because you are giving people, say, 50K, and it could be that the investment in stocks is so little that then the risky asset share becomes negative, the change becomes negative. Anyway, so this is what we estimate, that the change in alpha, which is the risky asset share, whether it is related or not to changes in wealth. But the change in wealth before and after the experiment is the wealth shock. And we are confident that nothing else changes before and after people actually did the question. And so the L, which is the hypothetical lottery, the genuine hypothetical shock. So this is what we find. We find actually that the relation is quite flat. So we find actually, so this is the change, and the change you see is effectively zero, except that for the largest lottery, but there you see the regression, the increase in the asset share is about 1.6. So in the end, we conclude in this paper, which is actually, we're actually revising it, that although we cannot identify the coefficient of relative risk aversion, but this suggests that the CRRA, the constant relative risk aversion, is at least consistent with the data. If this is so, this also implies that there is a lot of heterogeneity in constant relative risk aversion in the population. If, on average, this does not react, I mean, one can think that everybody has a risk aversion that is constant but different from each other, and this is I think an insight that may be useful also for macro. So let me summarize what I think one can maybe use from these papers, some common themes. I think these types of experiments, at least in the context of consumption, are useful, but they are particularly useful when one can use them to connect them with theory. So you can you start with a model, and then you develop some implications, like the first paper I talked about, say beta is equal to 1. Of course, in a way we were, I don't know, lucky or unlucky. Suppose we find that instead of beta is equal to 1, we found beta is equal to 0. I mean, we don't have an alternative model, we just can reject that model. So it's a bit risky in a way. So you can test specific hypotheses, but then I don't think this is enough. Once you test specific hypothesis, you want to compare your results with other empirical studies and perhaps also do your own simulation. The other point I think is that in most of these experiments or survey questions, subjective and so forth, one needs to identify things, and to identify things cross-section are usually not enough. So to achieve identification, you either have to use panel data. That's one possibility, but of course it's more time-consuming, and you need to have access to some data in a repeated period of times. Another possibility is to do randomization, so you can within one survey. Another possibility is to ask the same person more than one question. So how would they behave in various situations and try to identify things. There was mentioning we ask similar hypothetical questions, for instance, on lottery, to get some estimate of what labor economists call the pure income effect on labor supply. We also on search, you can, which is I think an important topic, given that when people receive income support, one claim by many is that people reduce search. And then we can we've been doing some work also on positive and negative house price shocks on consumption, trying to distinguish idiosyncratic house price movements from more general price movements. This is enough, and I hope I have time for some discussion if you want. Okay.
So for the first paper, there's two ways that you can do if you have a gap. Mm-hmm. One is that you save more.
Let me go back to the figure. This was
exactly. So there's two ways that you can deal with, and three ways that you can deal with a gap in target, in wealth to target wealth. Mm-hmm. One is if you save more or less. The other is if you decide, no, I don't want to save. This is not my target. You adjust your target.
Sure. What do you mean? You want to change your target?
Sure.
Well, but then remember, okay, but the target. So yes, but the target here depends on this set of parameters, income borders, and so forth. So what you're saying is that the, say, preference parameters change over time. Yes, we cannot address this. So the maintain assumption, we can get rid of the fixed effects of your, say, individual risk aversion, but yes, if you become lazy, say, as you become poorer and poorer, and you change your wealth, then we cannot address this. We would need even more data
Well, more to the point, when you look in the data within household, do you see that people change their target to the
No, I told you, when we the more, I think, intuitive thing here is that, so take consumption growth, take consumption as a proxy for permanent income, okay? So here you have permanent income growth, okay, at the individual level, this panel. So some people have, say, 50% permanent income growth, means they receive the promotion, for instance. On the vertical axis, you see that these people have reported in the next wave, because this is data, precautionary asset growth. So these things are correlated in the panel, that target 20 is correlated. But it's true that, as the estimates show, there is noise in the data. So these things are correlated, but there is also a lot of variability in this target wealth that we do not capture just with permanent income. And in the regression here, it shows up as this sigma squared V, which is the variance of target wealth. And you see the variance is 1. That's a huge number. So this means that there is a lot of noise. Okay, we are all friends here, so I'm bringing this up, saying that, I mean, in the paper we say that there is a lot of variability, but this number is actually quite large. So it means that there are other things that we do not take into account, or maybe that can explain this, or should explain this. Maybe including changing preferences over time is in here at the individual level. Yeah.
So thank you for the very thoughtful keynote. I wanted to get your view kind of on big picture. When we look at studies like this that are usually done in Europe, how externally valid could that be to places like the States and Canada, especially with regard to the relationships that North Americans, myself included, have with unsecured debt? Because when you have your definition of cash on hand, like I've looked at the SHU and other kind of European surveys, and there just aren't that as many people who like borrow on their credit cards, for example. And in particular, there aren't as many who co-hold, where they borrow on their credit cards and have cash. So the net positions are a pretty good representation, whereas in Canada and the US, the net positions had a lot of heterogeneity for people who co-hold. So whenever I see something like cash on hand in these papers, I always think, well, is that going to be applicable in the United States or in Canada? So I want to see, do you think that
Well,
that's something you can
I can
address?
tell you that on this particular question, this question is asked also in the survey of consumer finance, and it's been asked consistently for many years. And in fact, when people are asked about, how much you think you should have in terms of sort of target wealth, the amount that here, the median here is like 20,000. In the US is something like 4,000 to 5,000, much less. Now, this could be because, different preferences, but it could be also because it's easier to borrow, or more, or maybe there's more insurance. So, I agree that this particular analysis or this particular model may fail in another context, but the proof would be to run it if it was possible. It's not possible at the moment in the US because we don't have panel data on target 12. The survey of consumer finance is a repeated perception. So,
And even in the SCF, they have the question about what would you do if you needed to get the money?
yeah.
And the number one answer is not use my savings, is I would borrow money from a friend or family.
Mm-hmm.
So even like informal markets like we were talking about today seems
Yeah.
to be the predominant thing that people do instead of relying on their own savings.